So our problem is longest flight route from CSES. Now the problem is you are given n nodes and m edges. And first of all, this is a directed graph. And second, there is no cycle. So note that there is no cycle. You have to find the longest path from source node 1 to destination node n. In this case, n is 5. So there are two paths from source to destination. From 1 to 5 there are two paths, that is 1 to 5. So first path is 1 to 5, second path is 1 3 4 5. You have to print the length of this path and this path itself you have to print. So now see, you can think it like to solving this तरह. What you do in this तरह is to find minimum distance from a single source. Here you can find maximum distance, or you can say that you can multiply each edge weight by -1. So now you can find the, you can apply this तरह on this problem only. Single source shortest path. It still your problem is same, that you have to find the minimum distance from this node to all the nodes. And you know this तरह uses greedy approach. So you basically use min heap in this तरह, and here this तरह will pass here because of monotonic function. All function are decreasing, all distant function are decreasing. So here, but in the large test case this तरह will won't work, because test case can be tight, like some nodes can come into this your heap so many times, so it will lead to TLE. So it is always referred to, don't use this तरह in negative edge weight even though it is monotonic. Now try to use BFS, DFS or topological sort. Why? You know, in topological sort, if there is a node from U to V and it is a directed edge, to say anything about node V, you must know about all of its ancestors or all of its neighbor that are coming towards node V. If you know all the neighbor, all these such neighbors that are coming from V, you can, then only you can tell the answer of this node. So in this case also, see how this problem work. As you know, this is the source node, so there is, this node are not dependent on any other nodes. So we can say that distance, this is the distance vector, and each distance is initially infinity, and distance from, basically, just 1 second, this is distance of I from node 1. So from node 1 to node 1 distance is 0. From node 1 to node 2 distance is something. From node 1 to node 5, for like this we have to find the maximum distance. Now see, this node is not depend on any other node. Basically in degree for this node is 0. So you can come on to conclusion for this node. So you come like the answer for the distance from node 1 to node 1 is 0. Now this node is depend on this node 1, and you know answer for node 1. So what would be the answer for node 2 with respect to node 1? 1 from node 1, the answer for 2 is 1. So distance is 1. What would be the distance for 3? As you know all of its ancestors, so you can say distance is 1. Now the in degree of these two are 0, so now you can explore these two and you can remove these two nodes. So distance of, we are writing distance here. At this moment, can you say, can you decide distance for this node? With respect to this, distance would be 1 plus 1, 2. But what about with respect to this? You can't say. That's why we are saying that in degree is matter here. Basically topological sort. And it is given that there are no cycle. You can use topological sort, and it is also called Khan algorithms. All right, so at this moment you can't say anything about this node, as you don't know all of its ancestors answer for all of these ancestors. But you can say answer for this because you know answer for this. So answer would be distance from node 1 to node 4 would be 2 with respect to 3, because you are coming from 3, and you as in this question you have to print path. Then whenever you have to print path, you have to keep track of their parent. Like parent of 3 is 1, parent of 4 is 3, parent of 5 is, it will 4. So now you can, as you know answer for all of its ancestor, you can find answer for node 5. How? Go to all of its neighbor and update this node by 1 plus maximum of all of its neighbor value. So 1 and 2, maximum is 2, as you have to find the maximum distance. So the answer for this would be, initially it was 2, now it would be 3. So initially it was 2 means initially parent for parent of 5 was 2, but now its distance is 3, and that comes from here. So parent of 5 would be 4. As you know, now you have parent array, distance array. Now I will show you code. So whenever there is no cycle and edge weight are constant, means edge weight are constant like 1, 2, you can use in degree concept, as it is also called dependency. Like node 1 is not depend on any other node, so we can calculate answer for this. And to calculate for any other node, at the moment you must have answer for all of its ancestors, then only you can say answer for this. So that's why if we know answer for this, we can remove these two dependency will be still there, but we know answer, so we can also find answer for this node. And again, there is no cycle, so you can't say there is a node like this. If there is a cycle, you can't use topological sort. If there is a cycle, there is one more, there's few other problems like course schedule on lead code or on CSES platform also, course scheduling. You can solve this. You have to find that there is a cycle exist or not in your directed graph. If there is a cycle, then by applying topological sort, you can't get all the nodes in your set. There will be still let's see, like there is node 1, 2, 3. So there is a cycle. To find where would you start in degree of, let's say this is 4, so you start from 4. The in degree of 4 is 0, so you can start, but in degree of 2 is not 0, so you don't have any nodes which in degree 0. Node 2 is still depend on node 1. To find answer for node 2, we must have answer for node 1. To find answer for node 3, you must have answer for node 2, because 3 is depend on 2 and 1 is depend on 3. So there is cycle, you can't break this cycle. So whenever you have to find cycle in directed graph, you can apply topological sort, and it is given that there is no cycle, then still you can apply topological sort, because by applying topological sort you will explore all the nodes. Now we will see code. So see here, first we just one second, yeah. So first we took input n and m, that is the number of nodes and the number of edges given, and initially we decide parent for each node is -1, and distance from node 1 to each node is as we have to find the maximum distance, we keep this as minimum. This is a negative number. And in degree is 0. In degree means the number of nodes coming towards that node, the number of incoming nodes. Now we took all the edges and make directed graph, and edge of weight of each edge is 1 from U to V, and if there is a connection from U to V, then we can say there is an incoming edge to V, so we can increase in degree of B by 1. Now this is not necessary, as we can start from node 1 only. Now see, distance from node 1 to node 1 is 0. Because in degree is 0, we can say answer for this. Now we go all the neighbor for u, this node. Like here, we go all the neighbors. Just wait a second. Yeah, see, we pop this node and we know answer for this node. So that's why the in degree of this node is 0 and we know answer for this. So we can reduce in degree of this 2 also. This in degree of 0 means this node is not depend on any other node. Okay. So here we are saying that if distance of u, if distance till here plus 1 is less than the already existed distance, then you can update this distance. As you can see here, the distance from 1 to 2 was 1 and 1 to 5 was 2, but from this way distance was 3. So 2 plus 1 is greater than this 2 already existed. Then we can update this node and we will assign parent of this 5 would be 4. So same thing we are doing here. And once we pop this node, we can say all the neighbor of its node we can decrease in degree by 1, and if in degree is 0, we can explore that node. And at the end, if we can't reach from node 1 to node n, then we will say impossible, that there is no way to reach node 1 to node n. And if we can reach, then we will say the 1 plus distance of n. Why? Because we assign distance of 1 is 0 initially, but you have to count this as well in answer. And after that, whenever you have to find path, you have to store a parents, as we already have. Now we create a path vector, and first we push, like first we just see here, first we push 5 and we know parent of 5 is 4, then we push 4. See here, first we push 5, then go to their parent, push 4, then go to their parent, push 3, then go to their parents 1, then go to their parents, that is -1. Whenever we got -1, then we stop, and this is our path. Just we have to just reverse it. So as you can see here, at the beginning only we set all parents for all the nodes is -1. So it parent for 1 is still did not get updated, so parent of 1 would be -1, and when we got the parent is -1, then we will stop. So now we have path, and we can reverse it and we can print it. And one more thing, if you have any doubt like how to solve using DFS or why Distra will not work, anything, we can talk in comment section, you can ask in. Okay, we can discuss basically.